In this video, we'll review confidence intervals for population means. So a random sample of 50 12th grade students from a certain community was asked how long it took them to get to school. And the sample mean was 16.2 minutes, and the sample standard deviation was 12.3 minutes. Construct a 95% confidence interval for the mean commute times for all 12th grade students in this community. So the confidence intervals are based on the central limit theorem. So just as a reminder, the idea behind this process is you need to make sure the central limit theorem can be applied. So in this case, we have a sample size of 50, so n is greater than 25, so we could apply the central limit theorem. And so what would the central limit theorem say? It says that samples of 50 students, their means will vary from sample to sample, but the shape of their distribution will be like this. The center will be at the population mean. We don't know what the population mean is, and so we're just going to use our sample mean as a placeholder for it, our best approximation for the population mean. And then we can compute the spread of this distribution by taking our sample standard deviation and dividing it by the square root of n. And then by finding a multiplier to multiply by to get 95% of the distribution within the bands of the lower limit and the upper limit, then we have our confidence interval. And all of this information we let technology do for us. Because if we're not going to use technology, we would have to learn how to use and interpret a t-table, because this distribution, while it looks like a normal distribution, is really something called the t-distribution, which you read about in the reading and also in the guided notes that I provided. So that's just the background. In practicality, what we do is we use technology. And when we use technology, we go to StatCrunch, and I'll go there in a moment. But you're going to put in your sample mean, you're going to put in your sample standard deviation, and then you're going to say you want the 95% confidence interval. Okay, so let's go ahead and do that. And then we'll talk about the homework in a moment, okay? So let me jot down somewhere, because when I go to my iPad, I can't see this information. So our sample size is 50. Our sample mean is 16.2. And our sample standard deviation is 12.3. Okay, so now remember, in the previous video where we reviewed the central limit theorem, we had to be careful and we had to compute this ourselves. We don't need to do this computation in confidence intervals, because in the confidence intervals, StatCrunch will do that calculation for us. So let me show you how that works. Okay, so we're going to come here to Stat, T-stats, because we're using the t-distribution. I'm demonstrating it with one sample, and I have a summary. All right, the sample mean was 16.2. The sample standard deviation was 12.3. And the sample size was 50. So by entering the sample mean, the sample standard deviation, and the sample size, what StatCrunch will do for us is draw that picture. It will find the standard error for that sampling distribution, and it will use it to find the confidence interval. So we don't have to do any of that work by ourselves. So we just say we'd like a confidence interval. We check that we want the 95% one, and then we just press compute. So the lower limit is 12.7, and the upper limit is 19.7. So let's go ahead and record that. So we have a confidence interval of 12.7 to 19.7. And what that means is that we're 95% confident that were we to ask every 12th grader in that community, hey, how long does it take you to get to school? And we found the average of all those numbers, it would be somewhere between 12.7 and 19.7 minutes. Find the margin of error of the confidence interval. This is exactly the same as we did with proportions. Our sample mean is in the middle. So our sample mean is 16.2. Our upper limit is 19.7. Our lower limit is 12.7. And the margin of error is simply this distance between these two numbers. Or you could subtract these two numbers if you wanted. They're all the same. It's symmetric. So if you take 19.7 minus 16.2, you get 3.5. And so our margin of error is 3.5 minutes. Would you believe the mean commute time for 12th grade students in this community is 15 minutes? Why or why not? Well, what the confidence interval provides you is the range of values which are believable for the population mean. And so is 15 minutes in this interval? Yes. So I would believe this. Why? Because 15 is in our interval. I wouldn't believe 25. I wouldn't believe 30. I wouldn't believe 10 because none of those are in the interval, but 15 is in the interval. Now let's talk about your homework. That is my fault. If you had trouble on the 9.3 homework, I don't remember which problem it was, but on the 9.3 homework, I picked a bad problem. And I'm going to explain to you why. And my apologies. It's my fault. I'm sorry about this, but I'm going to explain why you had trouble with that one particular homework problem. And again, I picked a poor problem. I apologize. It was my fault. All right. So in the one of the homework problems, I accidentally picked one that did not give you the sample standard deviation. So if you use StatCrunch and any technology, in order to do a confidence interval or a hypothesis test, you need three things. You need your sample size, you need your sample standard, your sample mean, and you need your sample standard deviation. When I picked the homework problem, I thought I picked one that gave you a sample standard deviation, but I accidentally picked one that gave you a standard error instead. So the standard error is not the same as the sample standard deviation. And it's the sample standard deviation that you need to put into StatCrunch to find the confidence interval. And so to do this problem, what you would have had to do, and again, this is completely my fault, I apologize, all right? But you would have to solve for the standard error. So for example, suppose they told you that the standard error, I don't know, I'm just going to make this up. Suppose the sample size was 40 and you were told that the standard error is, I don't know, 4.7. Again, totally making up these numbers. Okay, what do we know? We know sigma over the square root of n is equal to, or s over the square root of n is equal to your standard error. Okay, so what you would have to do is you would have to solve this for s. Here, let me clean this up a little bit. So you would have to solve this for s in order to be able to use then technology to make the confidence interval. So for example, in this problem, you would have the standard error 4.7 is equal to s over the square root of 40. You would have to use the miracle of algebra to solve this for s. Multiply both sides by the square root of 40. And then using a calculator, you would have a value for s that then you could put into StatCrunch and find the confidence interval. Are you going to have to do that on an exam? No. My fault. Why is this problem in the homework set? Good question. This problem is in the homework set because there are some people that feel that there should be algebra in statistics. And so occasionally there are problems included in the homework set that involve a little bit of algebra. So anyhow, I didn't catch this. I thought they had given you the standard deviation, but instead they gave you the standard error. If you only had the standard error, you would have to solve for the standard deviation. The reason this doesn't come up in real life, and the reason I'm not going to dwell on this, is because notice, in order to compute the standard error, you had to know s. And if you knew s, then what the heck? You just put it right into StatCrunch. You don't need to solve for it. So again, this problem, my apologies. The standard error is not the same as the standard deviation. That's why you had trouble with this homework problem. It's my fault. You can do it by using algebra to solve for S. You'll never have to do this on an exam. On an exam, you'll always have the sample standard deviation just given to you in the problem. So I hope that helps. And again, don't stress over that one problem on the homework. And again, my apologies for picking a terrible problem.